Okay, so lesson 2-5 for Algebra 2, completing the square. Solve a problem like this by completing the square, and it goes something like this. If you can write the right side of this problem as a perfect square, then you can solve it by undoing your operations, undoing a square with a square root. So just in general, it starts off with x plus, and you do half of this 10. I'll show you on the next slide why that is in a picture form. And you put a square on there. So is x plus 5 times x plus 5. Now this one is set up to work out. It won't always be like this. It doesn't work that way in the real world. But x times x squared, 5x is 10x. And 5 times 5 is your 25. So that does match my original problem up there. And it does then still equal to 81 on the other side. Well, how do you undo we're trying to get x alone, right? That's what it means to solve. Undo a square with a square root. Don't forget a positive or negative. Again, I think I've said this before, but if x squared is 25 and I ask you what's x, most people immediately say 5, and I say, well, that's half the answer, so you got half the credit. And what about a negative 5 times negative 5? Is that not also 25? So don't forget, when you square root both sides to solve it like this, you do have to add a positive or negative, because a positive squared or a negative squared of the same number also equals the same thing. So up here in this problem, add this positive or negative here instead of in front of the square root of 81. So I have a positive or negative 9 there. The square root undoes this square. Subtract 5 from both sides, or that's the same as adding a negative 5 to the positive or negative 9. Negative 5 minus 9, negative 14. Negative 5 plus 9, positive 4. So there you go for the completing the square and why that can be helpful here in solving that problem. Well, if we look at doing it in pictures, so if I take that last problem, the x squared plus 10x plus 25, if you've never worked with tiles, you might be just as well off just memorizing the way this works. However, if you've done tiles ever, they're based on the area of the tile. So an x squared tile is one that is x by x, so that the area would be x squared, length times width. The 10x's, if you split those up evenly, because overall when we're done we want a perfect square. So this is 1 wide on each of these by x to match this x here. So 1 times x, the area of this each of these would be an x. And if we want to evenly distribute them on the length here and the width over here, so we're going to split those 10x's sort of like that. These are all 1s on this width. This x here matches that x there, so therefore these are all 1 by x or area of x as well. And then last but not least, out here, if you continue these lines out and down, everything is 1 by 1. So this is 5 1s, this way 5 1s. So inside of here, we do have my 25. So there's my 25. 5x's and 5x's make this 10x, and my x squared right there. So in tiles then, this shows this side x plus 1, 2, 3, 4, 5, and on this side x and 1, 2, 3, 4, 5. So x plus 5 times x plus 5, like area, length times width, equals the sum of all the parts inside of this square or rectangle here, which was x squared plus 10x plus 25. So that's how the tiles work to show it in a picture form. Well, what happens if one of them isn't like exactly a perfect square? Let's just quickly take a look at one where that might happen and see how we'll have to adjust for that. So let me erase everything I've got here for a second. Change to a new problem. And how that one would work now is, so let's say it's x squared plus, I don't know, something that's, let's keep this middle term even for now, so we don't have to deal with fractions this early for you. But let's say it's 12x and then plus 10, because 10, I don't think 10 split evenly is gonna be 5 and 5. That doesn't add up, or it's not gonna work out to give us our middle part here. So again, my x squared, x by x, split these 12 evenly, so now I'm going to have 6 of those out here. And then those are 6 x's, right? 1 by x. These are all 1 on this edge and x on this side to match this one over here. So 1 times this x gives you an area of x on each of those. Add all those up. Then go to the bottom down here. Split them evenly. So if we had 6 over here, we want 6 over here. So that's that whole thing where we're taking this term and divide by 2. And that tells us how many we're going to have on this side. So that's like a 6. This is like a 6. And then last but not least, on this one, I've only got 10 ones. So if I fill up 10 of these, for example, that would be 6 ones right there. I need another 4. But then everything outside of there is stuff that I'm short. So all of these, I don't have enough to fill all these up because I only had 10 ones. If it's 6 by 6, I needed 36. I've used up 10, so how many am I short? I'm short 26. So let's see how that would write out in the completed square form. X plus 6 squared. This is because right here, split the 12 in half, that's the 6. After that, 6 squared, I have 36 now, but I'm only supposed to have 10. So what do I have to do out here to make this problem right here the same as the original? 36, subtract 26, and that's how you would do it in a completing the square form. So if you have to, you can go back and watch that again. Now, how would we use that to solve an equation? So if I want to solve this, it doesn't factor, I don't believe. So let's see how we could work it out. X minus half of the 6, 3. I have right here negative 3 squared, which is 9. Negative 3 times negative 3 is positive 9. I need 10, so I need a plus 1 out here. Well, if I subtract the 1 to the other side, I've got a negative 1 equals the x minus 3 quantity squared. Square root both sides. To undo the square, don't forget a positive or negative. And then that leaves me with just the x minus 3. Remember, square root of negative 1 is the I that we had previously. And lastly, add that 3 over. So this one gave us what's called an imaginary root, and we'll talk about that more later, but there's my 2 solutions. Let me make one up, though, that doesn't come out like that. I probably shouldn't have given you one where it was going to be an imaginary one first. That would have been a better second example, but let's just say that instead I have something that looks like, I don't know, let's just put a 12 out here. So on this one, let's give you a different number here. Instead of that 6, we just did one that had a 6 there. Let's put an 8 in there. So let's see. X minus half of the 8 would be 4. Now I have 16 positives. I'm supposed to have negative 12. I have 16, I'm supposed to have negative 12. So what do I have to do to 16 to turn it into this negative 12? How about subtract 28? If I have 16 and I take away 28, would that get me back to my negative 12 I'm supposed to have? Negative 4 squared, right here, that's 16. But I'm supposed to have negative 12. So what has to go out here? Will that take me back to my original problem? So then, if our goal was to solve that for equals 0, here's in completed square vertex form. I would remind you that your vertex, if this was a quadratic with y equals, would be at 4, negative 28 there. Remember, the opposite on here, same sign as there on my y for your transformations. Add your 28 to the other side. Square root to the x minus 4 quantity squared side with a positive or negative then. And you're going to have x minus 4 equals positive or negative. 28 is 4 times 7, so the square root of the 4 part would get out as a 2. With that 7 left inside, I chose that 4 intentionally so it would get out. Just a reminder of that's simplifying radicals, and add your 4 to the other side. Final answer, 4 plus or minus 2 square roots of 7 for your x on that problem. Moving right along. You can go back and watch that a little slower if you need to. Sometimes they'll give you a word problem. So on the word problem I created here is, you've got this cow here that's out here in this field. You know it's a cow because it says moo. All right. And that cow, they know that they have, this over here is not needing a fence because it's a cliff. If the cows jump over, I guess then we'll have to talk about going back and adding a fence later. But the rancher says for now, don't worry about putting a fence there. So we need a rectangular pasture here. And on that pasture, the rancher wants 8,000 square yards and has 400 or 500 yards of fence to use. So how can we tell the rancher what the width and the length of this pasture should be? Well, what do we know here from the information they gave us? How many W's do we have? 2 of them, plus 1 length. And how much fence do we have to use? 500. And then what about the area that the rancher wanted? So the length times the width is your area, right? So 8,000. And then to solve this, I think I would do substitution. I would subtract this 2W over here. So I'd change this one into the length equals 500 minus 2W. And then I would replace the length right here with that if it were me. So then you could use a different method if you want to try and use some other method, but my length, 500 minus the 2W from over here, in place of this length times my W, my width, and my area was supposed to be 8,000. Now I have one equation with one variable. I should be able to solve that. Distributing the W here, distributing the W onto this 2W, W times W is W squared. And then, looks to me like all these numbers are divisible by 2 if we want to simplify this down. And then I'm going to move everything to that side at the same time. I hope I don't lose anybody here. But I'm going to divide by 2. That makes this one, when I move it over to the right, 250W, and it's going to be negative. This one's going to be -1 added to the other side will be my W squared. And then this plus 8,000. So if I was going to do this as a completed the square form, I'm going to have W minus half of 250 is 125. And then I'm going to grab a calculator. 125 squared 125 squared right now. I have 15,625 from that. And I'm supposed to be at 8,000. So I've got to take a whole bunch off from here to make the 8,000. So that's going to go outside here, and I'm going to just subtract that. So 15,625. I'm going to take off the 8,000 to see how much I really need to take out. 7,625. And it's going to equal 0 now because I moved everything to one side. And solve it by undoing my operations. So if I added that to the other side, I'd have 7625 equals the W minus 125 squared. Square root it. Don't forget your plus or minus to undo the square on the other side. And then lastly, add the 125 over. So let's check out the square root of 7625. And I'm getting like a weird decimal for that. So this is going to be an approximate answer. Approximately, it's like 87.3 for that, plus or minus, or 125 plus or minus that. So if I take 125 minus that, I've got something in the vicinity of 37.7. And if I take 125 plus that 37.7-ish number. No, that's not what that is. The 87.3. This is 87.3-ish. So 125 plus the 80, and then that one gives me somewhere around 212.3. So if you take two of these, because we have two W's, and then we could figure out our L. So 2 times the 87 number is 174 point whatever, 0.6. And then if I had 500 yards of fence, that's like 325 for the length. And then I'm curious what happens with this one, because I'm wondering if that's the 212. If I take 2 of the 212s for width, that uses up 424.6 of the yards, and then subtract away the 500 off from that. That gives me like this 75.3-ish sort of number. So if I made a mistake in there somewhere, I feel like there maybe shouldn't be two answers, but the process is what I'm after here. I hope you followed some of that. Go back and look at that again if you want, but that gives you kind of an overview summary of completing the square that is less than 2-5. There might have been one other problem here. If you're going to write an equation in the vertex form, we've kind of been doing that with all of these, but we'll just do it quick. So if I have an x squared minus 6x, and then let's say it's minus 15. So if I do the completing the square, x minus half of the 6 is 3. Right now, negative 3 squared is 9 positive. I'm supposed to have a negative 15. What do I need outside here? If I have 9 and I want to turn it into a negative 15, I'm thinking negative 24. Is 9 minus 24 negative 15? Or if you added these two together, does that give you the 24? And so vertex form, if I gave you this as the original equation, x squared minus 6x minus 15, vertex form would be y equals -3 minus 24. And then my vertex, reminder again, my vertex is, this is my x value, the opposite. So if it's a -3, +3. And my y, if I'm down 24, that is still down 24. So there's my vertex, check. Graph it. So put my vertex on the graph approximately at 3, -24. My y-intercept, that's always easy to pluck off. Since x is 0 on the y-axis, you put a 0 in for the x's. The only thing left, that's 0 squared minus 6 times 0, 0. They both go away. -15. So if I've got a -15 here, that can easily set another point that needs to be on my y-axis. And then don't forget, we know how to find the x-intercepts. So x-intercepts, for a lot of problems they ask this, x-intercept, what does y equal? Y equals 0. So then to solve this, add my 24 to the other side. Square root both sides. Remember the plus or minus, positive or negative. So I've got a positive or negative square root of 24 equals x minus 3. And add 3 to the other side. I would also remind you that for the square root of 24, because 24 is 4 times 6, that under the square root, the 4 gets out as a 2. So in simplified form would be 2 times the square root of 6. So on the left would be the negative, the minus, so 3 minus 2 square root of 6. And the one on the further to the right would be the bigger one, which would be when you're adding. And those could be decimal approximation as well. So I think that finds all the key points on the graph, and that should wrap up lesson 2-5.